Okay, so for this particular problem, the boundary conditions are that we know the temperature here at the base of the fin, so at R equals Rn, and that the tip of the fin out here at R equals R out is adiabatic, right? We can have different boundary conditions, but this is what we'll do for this problem. So here mathematically stated is the boundary condition at R equals Rn, and then here is the boundary condition at R equals R out. Minus K A dt dr has to equal to 0, and since K and A aren't equal to 0, the gradient has to be equal to 0. So it's just a matter of substitution then. I'll take this equation and substitute it into each of these different boundary conditions. So the first one's really easy. You just plug in TB here for T, and every place I have an R, I plug in Rn. So I get this equation here. That's one algebraic equation now in C1 and C2. So I need another algebraic equation, and that requires me to take the derivative of temperature and set it equal to 0. So I have to take the derivative of these two modified Bessel functions, and this is where you need to go back and maybe look at this sheet. So we're taking the derivative of the modified Bessel function of the 0th order modified Bessel function of the first kind, and apparently that becomes the first order modified Bessel function of the first kind. And then you're taking the derivative of the 0th order modified Bessel function of the second kind, and that becomes minus the first order modified Bessel function of the second kind, right? And I wouldn't expect you to know that, but it's easy enough to look it up on a sheet like this if you need it. So if we go back to here, yeah, I just turned Bessel I0 into Bessel I1, and of course you have to take the derivative of what's inside of here, so the m comes out. And I turned Bessel K0 into Bessel K1. Again, the m comes out, and that one switches signs. So here's my second algebraic equation that I use for C1 and C2. And at this point, I can be done, right? I'll just plug this equation and this equation into ease, and we will let ease solve for C1 and C2. So let's find ease here. So here I made up some inputs, right? And here's that m parameter. And then this is my boundary condition at the base. And this is my boundary condition at the tip.